Kia ora. Well, that's the way we say hello in New Zealand. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics. Now, children, before we get started, let us quickly have a look where we are going to have our class today. This is Mount Cook National Park, South Island, New Zealand. Here, you can take a 10-kilometer trek on the Hooker Valley route, which is partially paved. Here you get to see hanging bridges which have scenic look through it, and you can then move on the path where you have low elevation that is family friendly, which takes you to Hooker Lake, where there are floating icebergs waiting for you. I'm sure you can imagine this awesome scenery and you are soaked into it. That's great. This is where we are going to have our class today. And when you go to New Zealand, make sure you have pavlova, which is the mouth-watering sweet dish, I can tell you. Do tell all the people of New Zealand that you get to meet kia ora. And in this note, children, I'm again going to say kia ora, but at this time it is going to be to the topic that we're going to study today, that is functions. Now, children, when we talk about functions, there are different type of functions. Today primarily we'll be looking up logarithmic functions. Now let me quickly tell you about what functions are, right? And then we look up a few rules of logarithms, and then we look up an interesting sum. So children, when we talk about functions, functions are some special relations. Right? Now you will say, what is a relation? A relation is actually an ordered pair. That means in simple brackets, when you have one term comma another term, right, which is the first term to be the element of domain and the second to be the element of range, right? So you have something like this, like 3 comma 4, right? You call it to be a relation, which actually has come from the Cartesian product of two sets, right, where you have one set and from it you take first elements, then you have another set, from it you take the second element, and thus you form your ordered pairs. Now when we've already had our relations, then this relation can be a function if it satisfies a few conditions. Now the condition is this, that when you're choosing elements from the first set, it should be fully used up. That means no element should be left over in the first set. Then when we talk about the second set, it is known as the codomain set. The codomain set can have a little extra elements, there is no problem. The next thing is, when we talk about linking these elements, then they can either be 1 1 or they can be many 1. If it is there, then you say that the relation is a function, otherwise not. Right? Now this was about functions. Now when we talk about a logarithm, right, this is just the antagonistic of an exponential form, right? So if, say, we talk about logarithm, we first require to talk about an exponential. Let's say we have some a raised to the power x, which is equal to b. Now if we want to write this in the logarithmic form, right, we're going to write it with the same base, the base being a, and then we'll exchange the top entities. That is, we'll have log b to the base a, which will become equal to x, right? So the earlier was the exponential form, and now if you talk about the next, it is the logarithmic form, right? So these are two forms which are used once when it is required, that is when the exponential form is required, and at the other time when the logarithmic form is required. Now here, children, we will quickly be discussing a few rules with regards to logarithm. So if, say, you talk about log of a, which is multiplied with b, right, then we can write it as log of a to which log of b can be added. Right? Obviously the base, whatever it was earlier, will remain to be the same later. Now after this, children, if, say, we have some log of a which is divided by b, then this is going to become equal to log of a minus log of b. After this, children, we have another rule which tells us that if we have some log of a which is raised to the power m, then that will become m times of log of a, right? So these are some essential rules, and you have to remember one thing, that never talk about log 0. Log 0 is something which is inappropriate. It is something which is not possible. And remember that log 1 to any base is always 0, right? So these are the few rules that you require to remember. I'll just quickly remind them to you. When we talk about the two forms, they are either the exponential form or the logarithmic form. In the exponential form, you have things in the exponent. There is some base, there is some exponent which is known as the power index also, and if that's equal to b, right, if you write it in the logarithmic form, you will write it as log of the same base, but the top entities will get exchanged, so it will become log b to the base a is equal to x. Now when we have to deal with logarithm, obviously we should be knowing certain rules of it. So if, say, we have some log of a which is multiplied with b, then that can be written as log of a plus log of b. Now if we have log of a upon b, then that can be written as log a minus log b. Now if we have log of a raised to the power m, then that will become m times of log of a. So these are a few rules, children. Now using these rules, there is an interesting question which I'd like you people to first try, and then I'll help you out with it. But obviously after that, I'd like you people to practice the sum, because without practice in maths, if something new comes, or even if something comes which you've already done, you will not be able to do it perfectly. Okay, at this moment I can't give you more time. If you're offline, make sure you pause the lecture, give it a bigger try using the rules. Okay, children, in this question we have, if f of x is equal to log of 1 minus x upon 1 plus x, then we have to show this, that is f of a plus f of b is equal to f of a plus b upon 1 plus ab. So all of these f's actually are functions. So this question actually comes in functions. It should follow the rules of functions, and in that we are talking about logarithm to be a function, as our function f of x is logarithm of some number, right? So we'll be using the rules of functions as well as logarithm. So here, children, first what we require to do is we talk about the left hand side. Now children, in the left hand side we have f of a, to which is added f of b. So let's now talk about what f of a can be. So f of a is going to be equal to log of 1 minus a divided by 1 plus a, right? And further here to that is to be added f of b, so that's going to be log of 1 minus b divided by 1 plus b, right? Now children, here you get to see that there are two terms with log which are added. So you are quickly reminded that if you talk about some log of a plus log of b, wasn't it equal to log of ab, right? So we are reminded of it, and we can write this to be log of ab. So here, as such, this is what we are going to apply here. That is, in the next step now we can write this as log of 1 minus a upon 1 plus a, which is going to be multiplied with 1 minus b upon 1 plus b, right? Now for the next, what we do is we talk about the multiplication of both of these binomials. So in the numerator we'll have 1 minus b minus a plus ab, and in the denominator we will be having 1 plus b plus a plus ab, right? And this is all that we can do in the left hand side. Now we've got to move over to the right hand side and try proving it equal to the left hand side. So when we talk about the right hand side, children, this is another f of some constant which is a plus b upon 1 plus ab. So we've got to prove this to be equal to f of a plus b divided by 1 plus ab, right? Remember children, after you understood these sums, unless and until you practice them once, my hard work for you people to make you people understand different topics will be lost. So don't let that happen, right? Do work hard, do these sums once more, so that when they're asked or similar type of questions are asked to you, you are able to do that really well. Okay, so children, now here when we talk about f of a, remember it was rather f of x, it was 1 minus x upon 1 plus x. So this further is going to become equal to 1 minus a plus b upon 1 plus ab, right? And rather we'll do one thing more. Here we have, remember, log of this also. So as such, we'll be writing log of this also. Log is outside, and thus here we have log of 1 minus this entirety, and in the denominator we have 1 plus this entirety, that is a plus b divided by 1 plus ab, right? So children, as this was f of x, which could have been written as log of 1 minus x upon 1 plus x, as such here we have written log of f of a plus b upon 1 plus ab to be 1 minus a plus b upon 1 plus ab divided by 1 plus a plus b upon 1 plus ab. Now here further what we can do is we can take LCM of the fractions, and when we do so children, we'll have 1 plus ab here, and from that is subtracted the sum of a plus b, and in the denominator we are going to have 1 plus ab, and further children, in the denominator we have another fraction to sort out, and we'll sort out by first taking the LCM, which becomes 1 plus ab, the lone denominator, and then in the numerator you'll have 1 plus ab, to which is going to be added a plus b, and that is all. Now I'm sure you're able to see that there is a fraction which is there in the numerator and another fraction which is there in the denominator, and they will have their denominators cancelled as they are identical. Obviously, when you have one fraction divided by another fraction, the second fraction is going to reciprocate, and as such you will have 1 plus ab, 1 plus ab, which will be 1 in the denominator, 1 in the numerator, which will get cancelled. Now children, with what are we left out? So this is going to become equal to log of 1 plus ab minus a minus b, and in the denominator you have 1 plus ab plus a plus ab, and we can simplify no further. So let's quickly try and match. In the left hand side we came to 1 log of 1 minus b minus a plus ab, and here also we have the same, and in the denominator we had 1 plus b plus a plus ab, and that is exactly the same. So as such you can say that this is equal to the left hand side, and therefore this stands to be proved. So children, I'll just quickly discuss the sum. In the question you've been given here that there is a function which is a logarithmic function, and f of x becomes equal to log of 1 minus x upon 1 plus x. Now we've got to show that f of a plus f of b will become equal to f of a plus b upon 1 plus ab. Now here what we do is we simply pick up the left hand side and write f of a as f of x was. So as such, f of a becomes equal to log of 1 minus a upon 1 plus a, and similarly adding to it, f of b will become log of 1 minus b upon 1 plus b. Now children, further we are to simplify, so we remember quickly a rule that we learned earlier in log just now. If we have log of ab, right, that means a and b are multiplied together, then obviously this becomes equal to log of a plus log of b. So here also, as they are added, that is there are two terms with log which are added, so obviously these terms whose logs are being found out, they will get multiplied. So obviously here what will happen is you will have here 1 minus a times of 1 minus b, and in the denominator you will have 1 plus a times of 1 plus b, and when we solve it out it becomes equal to 1 minus b minus a plus ab, and in the denominator you will have 1 plus b plus a plus ab. Right, now this is all that you can do. You can do no more simplification in this. Now children, we move over to the right hand side, and the right hand side says we want the left hand side to be equal to f of a plus b upon 1 plus ab. So as such here we now try writing f of this entity. As we know that f of x is log of 1 minus x upon 1 plus x, so we'll have log of 1 minus this big entity upon 1 plus this big entity. Now children, as there are fractions, so we will take an LCM. So the LCM will be 1 plus AB, as it is the only denominator, that is the lone denominator. So we'll have 1 plus AB minus A minus B. Why? Because minus sign is multiplied to this binomial. This is a horizontal bracket, remember, and as it gets multiplied to the binomial, in the next step it becomes minus A minus B. Now in the denominator, again we can take an LCM. It will be 1 plus AB again, and here we'll have 1 plus AB plus A plus B. And what will happen here is, as the denominators of the fractions in the numerator and in the denominator are identical, they will get cancelled. So further you'll just be left out with this and with this. Now you can multiply the minus sign within, so this will be 1 plus AB minus A minus B, and in the denominator you will have 1 plus AB plus A plus B. Now children, next we have to talk about matching this with what we had on the left hand side, and we find that we had 1 plus AB minus A minus B, which matches, and in the denominator we have 1 plus AB plus A plus B, right? And that is exactly what we have here. As such, we can say that this is equal to left hand side, and that is all that we're going to do in this. I'm sure all of you people must have understood this. Harsh, really? So children, make sure, especially Harsh, do a practice of this, right? And when you do so, then obviously when sums of this sort come, then you'll be able to deal it with ease. Bye children, have a nice time. Bye.